Hey there, everyone. Let's do this acid-base example. So you have sulfurous acid reacting with sodium hydroxide. So we need to figure out what this name is, sulfurous acid. So it's going to have H's out front, but this one is the SO3. It's not sulfuric acid, which is SO4. This is reduced down by one oxygen, so it's SO3 plus sodium hydroxide, NaOH, is going to yield water. And what's left over is your sodium sulfite. But how many sodiums do we need? 2. Because remember, the SO3 polyatomic ion is a 2- charge. Now we need to balance it. So I notice that there's 2 sodiums on the right-hand side. So I need to add a coefficient in front over here. Does that make everything check out? So we have 4 hydrogens on the left. We need to add, I think, 2 right there, 4 hydrogens on the right. The oxygens, we have 5 oxygens on the left, and we have 5 oxygens on the right, and 1 and 1 sulfur. I think we're good. Okay, cannot forget to balance these reactions when you're doing, any reaction, but now we need to do stoichiometry, so we definitely need the mole ratios between all of the molecules. So the question's asking what volume, right? So we have to end with milliliters or liters, okay? Now, we're also given information, we're given molarity of this guy. So this is the 0.100 molarity. What about over here with the sodium hydroxide? We are given 50 mils of its molarity. So we need to do some stoichiometry. In general, you want to start with measured amounts like volumes, grams, things like that, like a singular unit, and not a conversion factor. So remember, molarity is moles per liter. If I started with a fraction, then I somehow have to reduce that fraction into a singular unit. So it can confuse people many times. So in general, you want to start with the one singular unit value. And it's usually like the measured thing that you could potentially visualize in a, flask or on a balance. Okay, so we can, with this information, with sodium hydroxide, we can figure out how many moles there would be. That's what we can actually figure out. So once we have moles of NaOH, can't we go to moles of sulfurous acid with the mole-to-mole ratio? Now that we've balanced the reaction, we know it's a 1:2 ratio. Once you're given moles of sulfurous acid, if you want volume, you can get there in one step because you're given molarity, right? You're given molarity in the problem. So that's our little roadmap, kind of. So let's try to actually do the problem. I'm going to change color. So we're going to start with sodium hydroxide with that information. We're going to start with the measured amount, 50 mils of NaOH. Now I'm going to convert it to liters because we need to convert it to liters to be able to use it with the molarity conversion factor. So I have milliliters on the bottom, liters on top. In 1 liter, we have 1,000 milliliters. And I'm just going to keep going. You can stop and reduce if you'd like, but let's just do a long stoichiometric problem. So we would technically be canceling the milliliters and we would be at liters if we stopped here. Now we have this molarity. And remember, that's moles per liter. So liters goes on the bottom, moles on the top, because we need to cancel the liters. And what do they tell us? It's 0.100 per 1 liter of NaOH. We could stop here, but I'm going to keep going. Like we could stop and then restart on the next line if you'd like. But let's just keep on moving forward. Liters cancel. We're left with moles. Now we want to get to moles of this compound. So what is the ratio? Well, for every 2 moles of NaOH, we have 1 mole of sulfurous acid. If we stopped here, we'd be at moles, which would be cool. But we want to get to volume. We have molarity, right? We have its molarity right here. So we're going to say molarity, moles per liter. Remember, you can flip the fraction, but now what goes on the bottom is 0.100 moles per 1 liter. And at that point, it doesn't say report in either milliliters or liters, so you could stop at this point. And if you do the math, I ended up getting 0.0250 liters. Okay, 3 sig figs because of the 0.100 molarity. So this is what I got for the volume of sulfurous acid that would react with that much NaOH. So give it a try. Remember, balance the equation first, write it, balance it, and then do some stoichiometry to get to your end goal.